From Vandenberg Air Force Base in California, you're watching live coverage of NOAA's Joint Polar Satellite System 1, also known as JPSS-1, the first in the series of 4 highly sophisticated environmental satellites designed to increase the timeliness and accuracy of weather forecast. Hi, I'm Tori McLendon. Thanks for joining us. Last time we were here, launch was scrubbed due to upper-level winds and a range safety holds. Upper-level winds for potential launch attempts were predicted to be out of limits over the past 2 days, so November 18th was agreed upon by NOAA, NASA, ULA, and the U.S. Air Force Western Range as the next viable opportunity. This will be the third time we've fueled the Delta II, now scheduled to take flight with JPSS-1 at 1:47 a.m. Pacific Time from Space Launch Complex 2. For now, let's go to NASA launch commentators Mike Curie and Josh Finch, who are monitoring the countdown activities inside Delta II Launch Control. Mike and Josh, how are things progressing so far?
Thank you, Tori. Right now we're in a hold at the T-minus 15 mark. This is a 20-minute built-in hold, and we'll begin picking up the count at 1:22 a.m. Pacific Time.
We're about 30 seconds away from launch, and we expect our final weather briefing from Vandenberg Air Force Base 30th Space Wing Launch Weather Officer Captain Ross Mulligany in about 23 seconds. Like Wednesday, upper-level winds are carefully being assessed this morning. There is cautious optimism, however. Weather balloon data is trending favorably, so we will stand by to get a weather briefing momentarily that will cover both the launch weather and possibly the upper-level winds. Standing by for the weather briefing.
Attention on the Weather Conference Net. Stand by for the weather briefing. All stations acknowledge. ELWA.
Hello.
Delta RC.
RC.
LD.
LD.
NLM.
NLM.
OD.
OD.
SLIC.
SLIC.
OO provide current and predicted T0 status for safety and launch agency constraints and probabilities of violation.
This is the OWL. This briefing will be displayed on CCTV channels 9 and 10. Beginning with channel 9, current satellite loop indicates clear skies. Current radar loop indicates no significant returns. Winds at the 102-foot level of Tower 102 show east winds at 9 knots and steady. Turning to channel 10, currently there are no watches, warnings, or advisories in effect. For T0, we're expecting clear skies with a slight reduction in visibility. Temperature will be in the low 40s and winds will be out of the east at 7 to 10 knots. Range safety LTCs, we are currently green, forecasting overall POV of 0% with no areas of concern. For user constraints, we are currently green and forecasting POV of 0% with no area of concern. Going to backup day, we expect scattered high clouds with unrestricted visibility. Temperature will be in the low 40s. Winds will be out of the east at 6 to 9 knots. For range safety LCCs, we're forecasting a 0% POV with no area of concern. User constraints, 0% POV with no area of concerns. That concludes my briefing.
OO indicates clear to proceed. All stations report. Questions are acknowledged. OO.
Hello.
Delta RC.
RC.
LD.
LD.
NLM.
NLM.
OD.
OD.
SLIC.
SLIC.
Weather Conference Net clear.
And as you heard, weather at this point is 100% go. Winds 7 to 10 knots from the east. Temperature expected to be in the low 40s at the time of launch, which is about 28 minutes from now. 0% chance of probability of violation. Upper-level winds appear to be trending favorably at this point. So at this point, everything continues to go well. Managers and engineers from United Launch Alliance, NASA, and the Western Range will continue to assess the upper-level wind data to ensure it is within limits for the Delta II rocket and for public safety as we continue through the countdown. Josh?
The mobile service tower at Space Launch Complex 2 is rolled away early this morning, or early Friday morning, leaving the Delta II and NOAA's JPSS-1 spacecraft ready for launch. The MST is now parked about 300 feet to the southeast of the Delta II.
We're going to be targeting the middle of our 66-second launch window, and the new liftoff time will be 1:47:36 a.m. Pacific. That change to the countdown clocks is expected to be made at the beginning of the T-minus 4-minute hold.
Fueling operations began on time more than an hour ago, and both stages are ready for launch of the Delta II rocket. The launch vehicle is loaded with RP-1, a rocket-grade kerosene, and liquid oxygen. There are no significant technical issues being worked at this time. The Delta II rocket and NOAA's JPSS-1 spacecraft are healthy and ready for an on-time liftoff.
We're about a minute and 34 seconds away from picking up the count at the T-minus 15 minute and counting mark. We have one more built-in hold at the T-minus 4 minute mark. We'll be entering that 10-minute hold at 1:33 a.m. Pacific, and during that time, managers will conduct final readiness polls and give the final go to launch NOAA's JPSS-1. The Western Range is based here at Vandenberg Air Force Base in California and is overseen by the U.S. Air Force 30th Space Wing. The Western Range, like its East Coast counterpart based at Cape Canaveral Air Force Station in Florida, oversees launches from various customers. That ensures the safety of the public, aircraft, and maritime interests during launches.
It's a vast tracking, telemetry, and command complex consisting of electronic and optical tracking systems located along the Pacific coast that collect and process launch-related data for a variety of users.
Not only does the Air Force provide launch weather forecasts and upper-level wind data collected by weather balloons, but it also assesses whether any boats or planes have wandered into an exclusion zone, which is set up to ensure safety.
During the launch countdown of the Delta II with NOAA's JPSS-1 on board, the Western Range provides its go, no-go status. Only when the weather, the rocket, the spacecraft, and the range are all go status will we proceed to launch. The final range green can occur 1 minute before liftoff.
And the countdown clock's about to resume for the launch of NOAA's JPSS-1 in 3, 2, 1, T-minus 15 minutes and counting.
Second stage helium and nitrogen system pressures.
Earlier, managers received notice that there are no COLAs or collision avoidance cutouts to be concerned with, so there is a clear path for NOAA's JPSS-1 throughout the launch window. That provided NASA launch manager Omar Baez the latitude to move the launch time to the center of the window at 1:47:36.
About 30 minutes ago, the Delta II rocket first and second stage engines were run through a series of movements or slews to verify their ability to control the rocket in flight, and everything went well.
And so with that, we'll go back to Tori McClendon. Tori?
Thanks for the update, guys. The Joint Polar Satellite System, or JPSS, is a collaborative program between NOAA and NASA. JPSS is the nation's next-generation polar orbiting environmental satellite system that will gather a multitude of global measurements. The series of 4 highly sophisticated weather satellites will provide greater imaging, increased resolution, and faster coverage, which will increase the timeliness and accuracy of weather forecasts 3 to 7 days in advance of extreme weather events. NOAA's JPSS satellite system will provide weather observations through 2038. Let's take a closer look at this polar orbiting satellite system and its significance to the future of weather forecasting.
The National Oceanic and Atmospheric Administration, with the support of their partners at the National Aeronautics and Space Administration, will launch the JPSS-1 satellite, the first operational satellite in NOAA's next-generation polar orbiting satellite system. Join us for a front row seat to this launch as we take you inside the JPSS-1 satellite. With an ever-growing need for environmental data, the United States relies on NOAA's Joint Polar Satellite System, or JPSS. This system provides the next significant technological and scientific advancement in observations gathered from a polar orbit. The images seen here were captured by. Still in orbit, it continues to forge a path for the JPSS program. Every time you check your phone or TV for your local weather, you're getting a forecast that relies on information provided by 3 of JPSS's state-of-the-art instruments. The Advanced Technology Microwave Sounder, the Visible Infrared Imaging Radiometer Suite, and the Cross-Track Infrared Sounder are critical for weather forecasters at NOAA's National Weather Service. In fact, 85% of the data feeding today's weather forecast models come from polar orbiting satellites like JPSS-1. The ATMS instrument is JPSS-1's next-generation cross-track microwave sounder, providing information about the physical properties of our atmosphere, such as temperature and moisture. The CRIS instrument aboard JPSS-1 will be the most advanced infrared sounder ever placed in orbit. With over 2,200 channels, each observing a different layer of the atmosphere, CRIS provides meteorological data in greater detail than ever before. The VIIRS instrument collects visible and infrared imagery of Earth's land, atmosphere, cryosphere, and oceans, and produces a vast array of unique environmental observations. Some of our most stunning images of Earth from space, like the ones you see here, are produced by the VIIRS instrument currently being flown on Suomi MPP. CRIS, ATMS, and VIIRS are essential for the National Weather Service and daily weather forecasting. JPSS also features two other advanced instruments. They are the clouds and the Earth's radiant energy system and the ozone mapping and profiler suite. The OMPS instrument monitors the health of the planet's ozone layer and continues a crucial global data stream produced by current ozone monitoring systems. JPSS-1's Ceres system is essential to understanding the amount of heat and energy radiating to and from Earth. While each instrument alone is an incredibly powerful tool for environmental observation, the 5 instruments aboard JPSS-1 are designed to work in tandem to provide a much more complete picture of environmental phenomena. JPSS-1 is an incredible machine. We are excited that you can join us as we see it off on its mission to continue a legacy of vital contributions to United States weather forecasting.
The Delta II rocket has a well-celebrated history with 153 vehicles previously flown. NOAA's JPSS-1 is the 53rd Delta II mission for NASA. The Delta II on this mission is flying the 7920-10 configuration, consisting of 2 stages and 9 strap-on boosters. In addition to JPSS-1, the Delta II rocket is taking up 5 CubeSats, which will be deployed in succession after spacecraft separation. Today's broadcast will cover launch activities through CubeSat deployment. As we previously mentioned, NOAA's JPSS-1 will launch atop a United Launch Alliance Delta II rocket. The Delta II is known for being an industry workhorse with decades of success. Let's listen as Tim Dunn with NASA's Launch Services Program talks about the history of this incredible launch vehicle that will send JPSS-1 into space.
Delta II has been a terrific rocket for NASA and our nation. Often heard it referred to as the workhorse for NASA. It filled a really critical space in launching the variety of NASA science spacecraft over the years. We've gone to other planets, Mercury,
and liftoff of Messenger on NASA's mission to Mercury.
Mars. We've gone to the moon.
Zero. Liftoff, Delta II with Ray.
Just a really special rocket filling the role for science. After almost 30 years of great service to our nation, Delta II is now flying out. We've got 2 last rockets. We're going to launch JPSS-1 in November of 2017 and then ICESat-2 in 2018. So you have 2 opportunities left to see this great rocket before it's retired.
And we have separation.
United Launch Alliance has a long-standing tradition of dedicating each mission to friends and colleagues who have passed on. Today's mission is dedicated to Eric Limon and George Dean. Eric began his aerospace career in 1970 as an Air Force sergeant working on the Thor missile program, which is the precursor to today's Delta II. As a principal facility electrical engineer, Eric worked tirelessly with the ULA team, the 30th Space Wing, and the Western Range at Vandenberg to ensure that facility electrical systems were properly configured for critical operations like today's launch. George Dean retired from Boeing following 43 years of service. As the move master for Huntington Beach operations, George supported the Delta II, III, and IV programs. Many of the critical move procedures implemented under George's leadership are utilized on the Delta today. George was kind and considerate and a mentor to all those who knew him. He is survived by his wife Jennifer and daughters Tori and Michelle. The memory of our dear friends remain and is a constant reminder to believe passionately in what you do and have fun doing it. We are now about 15 minutes away from launch, coming up on a planned hold in the count. So let's go back to Mike and Josh in the control center for an update. How's it going over there, guys?
Hi, Tori. Things are going pretty well here in the Remote Launch Control Center, also known as the LCC. Mike and I have been listening as teams are working through the steps necessary to lead to an on-time liftoff. We are just a few moments away from entering our hold at the T-4 mark. This is a standard hold in the countdown of the Delta II rocket, allowing managers and engineers to assess their systems and give a go, no-go status during a series of polls.
And as you know, over the last couple of launch attempts, we've had an issue with upper-level winds causing a concern that have put us into a scrub position. We're pleased to report that NASA launch manager Omar Baez is reporting that at this point, upper-level winds are within limits, and the western range is green and expected to remain green through the remainder of the count. So that is very good news. We also have a 100% go weather forecast, so no major technical issues are in work at this time. We're about 25 seconds away from going into our final hold at the T-4 minute mark, during which, as you said, Josh, a number of polls will take place, and we'll follow along to see whether we remain in a green stature. About to enter the hold in 5, 4, 3, 2, 1. T-4 minutes and holding.
Timer adjust for a new T0 of 094736 Zulu.
Roger, that's in work.
And as you heard, the liftoff time has been adjusted to 1:47:36 a.m. Pacific. NASA's Launch Services Program, known as LSP, is based at Kennedy Space Center in Florida and is responsible for selecting the appropriate launch vehicle for a mission spacecraft. In this case, the United Launch Alliance Delta II for NOAA's JPSS-1.
As liftoff nears, teams oversee the launch vehicle's engineering and manufacturing and its integration with the spacecraft. LSP conducts the countdowns for NASA's scientific missions and provides additional quality assurance to ensure a successful mission.
For launches like NOAA's JPSS-1 that require a spacecraft to fly around the world in a north to south orbit, known as a polar orbit, LSP manages launches from here at Vandenberg Air Force Base in California.
With about 13 minutes and 30 seconds until liftoff, we'll go back to Tori for more information about this mission from NOAA and NASA. Tori?
Thanks for the update, guys. The NASA Edge team had a chance to catch up with a few folks from NOAA and NASA about the JPSS-1 mission. NASA Edge's co-host Blair Allen spoke with John Demko, the resident office manager for the Launch Services Program here at Vandenberg Air Force Base, to talk about some of the processing milestones leading up to today's launch.
Thanks, Tori. We've learned an awful lot about JPSS-1 and the spacecraft today, but John, can you tell us a little bit about what happens to get that spacecraft here on the rocket and ready to launch?
So there's quite a bit of activity that happens once the spacecraft arrives. First, it's taken to a payload processing facility where there's several tests that are done and maybe some final assembly as well. They must fuel the spacecraft and then ready it put on the adapter that it will sit on when it goes out onto the rocket, and that all takes about 2 months worth of time.
Well, I was going to ask you about time. I see the weather is different at different stages of this process. About how long does it take to get everything out to the pad?
Well, so a typical Delta II process is about 60 days. However, because of where we are in terms of the history of the program and the period that we're launching between launches, they've stretched that out to about 120 days.
And talk a little bit about what's going on with the spacecraft and getting it actually mounted up on the rocket.
So once the spacecraft is put on the adapter and a can is built around the spacecraft to make the transport, it's put on a transport trailer and then towed out to the launch site at the base of the tower, lifted up with a crane, and then set down onto the rocket and then bolted to the rocket.
Now, I understand there are 9 boosters associated with this mission, and they're putting those on now. Is that a common configuration?
So it's a typical configuration. There's 3 configurations that have been typical for Delta II: 3 solids, 4 solids, and then the 9 solid that we're flying on this mission.
And I see here, that's the upper stage?
So that's actually the second stage. That's the third piece that's put into the puzzle. They do the first stage, then the inner stage that makes room for the nozzle of the second stage, and then the second stage is lowered onto the inner stage.
Now here we're seeing the spacecraft, and I've always had a question. They wrap that to take it out to the pad. Do they remove that wrapping once they're out at the pad?
Absolutely. That's a contamination barrier. The spacecraft folks are always very, very, very concerned about contamination, and so they always wrap the spacecraft whenever they're not doing an operation that requires that wrapper to be off. But indeed, once the spacecraft is at the pad, just prior to the fairing being installed, that type of enshroudment is removed.
And it's a pretty interesting operation getting that up onto the rocket.
Absolutely, it's a little hairy to watch, but and you have to be very concerned about winds. It's a very low wind threshold to lift that can. It acts like a large sail, but it is a smooth operation in the right kind of weather.
Awesome, thanks so much, John. Back to you, Tori.
For those of you just joining us, you're watching live coverage of NOAA's Joint Polar Satellite System 1, or JPSS-1, from Vandenberg Air Force Base in California. The United Launch Alliance Delta II rocket is poised to lift off from Space Launch Complex 2 at 1:47 a.m. Pacific Time. JPSS is the first in a new series of 4 highly advanced NOAA polar orbiting satellites. With that, let's go back to Mike and Josh in the Control Center for the final count to launch. Mike and Josh, how are things looking?
Thank you, Tori. Things are still progressing well for an on-time liftoff of the Delta II rocket with the JPSS-1 spacecraft. NOAA's JPSS-1 is now on internal power. NASA launch manager Omar Baez has polled his team. The Western Range has conducted its readiness poll. Launch conductor Scott Barney has asked the NASA spacecraft coordinator to configure NOAA's JPSS-1 for launch, and launch director Tom Heater has conferred with mission managers for their go, no-go status.
We're about 5 minutes, 6 seconds away from picking up the count and 9 minutes away from launch. At this time, everything remains green, pending the outcome of the final polls. Weather is go. Upper level winds have cooperated today. No major technical issues in work.
AC-1.
And LC.
Launch director Tom Heater and launch conductor Scott Barney working in tandem with NASA launch manager Omar Baez and his team as we count down toward the final minutes of this morning's liftoff of NOAA's JPSS-1 spacecraft. We'll be standing by for launch conductor Scott Barney to brief the launch team on procedures necessary to stop the count, should that be necessary between now and liftoff.
L-minus 8 minutes. All communications switch to Channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
If a condition that exceeds a launch constraint anytime after a terminal count status check, The observer shall announce hold, hold, hold on Channel 1, identify their station, and briefly state the reason for the hold.
About 7.5 minutes to go before liftoff. We're now standing by for Scott Barney to perform a final status check with all launch disciplines, scheduled for 7 minutes away from liftoff.
L minus 7 minutes.
Status check to proceed with terminal count. Report go, no go. Talker.
Go.
FSC.
Go.
Prop 1.
Go.
Prop 2.
Go.
PEA.
Go.
EEA.
Go.
VP.
Go.
SCM.
Go.
SYS.
Go.
FAC.
Go.
ATC3.
Go.
Timer.
Go.
HYE.
Go.
FMA.
Go.
SSC.
Go.
SSP.
Go.
GM1.
Go.
GM2.
Go.
BE.
Go.
ATC2.
Go.
VSE.
Go.
OSM.
Go.
FACA.
Go.
GE.
Go.
RC.
Clear to proceed.
That's TM. That's TM. Net 1. USO.
Go.
AC.
AC is go.
That's TM.
That's TM is go.
Launch Director.
LC, you have permission to launch.
Proceeding with the count. Note of personnel switch to channel 15 after liftoff is confirmed for pad securing.
Launch conductor Scott Barney has received a go from all stations to continue the countdown. We are scheduled to release this hold in just about 2 minutes and count down to an on-time liftoff of the ULA Delta II rocket and NOAA's JPSS-1 spacecraft.
1200 PSIG minimum.
And again, our liftoff time has been adjusted to 1:47 and 36 seconds a.m. Pacific time.
FAC verified manifold press is 160 to 185 PSIG.
Verified. L minus 5 minutes, 30 seconds.
And a half minutes away from coming out of the hold.
Spacecraft is configured for launch.
And NOAA's JPSS-1 spacecraft is configured for launch. On internal power, configured. The Delta II is standing by at Space Launch Complex 2 at Vandenberg Air Force Base for an on-time liftoff 5 minutes from
L
now.
minus 5 minutes.
LC established countdown limit conditions T minus 4 minute on.
On.
All personnel stand by for release of the hold.
All steps prior to the terminal count are complete.
"40 seconds away from picking up the count. Launch 4 minutes, 20 seconds away.
And we are standing by to resume the count in 5, 4, 3, 2, 1.
T minus 4 minutes.
T minus 4 minutes and counting.
FAC.
After
pad water
launch.
system enabled.
Enabled.
After launch, we'll hear the voice of United Launch Alliance's Patrick Moore providing a status of the flight of the Delta II and NOAA's JPSS-1.
First stage internal.
First stage
Second
of the
stage
Delta internal.
Internal. FAC, divert AC flows.
Roger.
Prop 1, vent helium umbilical as follows.
Roger.
T minus 3 minutes, 20 seconds and counting. Everything remains go.
T minus 3 minutes.
Prop 1, vehicle fuel tank press open.
Open.
Fuel umbilical purge open.
Open.
SSC, armed vehicle ordnance systems.
Active. SNA's armed.
First stage armed.
Second stage armed. Armed.
FSC, Bat 1 heater control, exit.
Exit.
Bat 2 heater control, exit.
Exit.
T-minus 2 minutes, 30 seconds and counting. NASA launch manager Omar Baez informed ULA launch director Tom Heater that NASA is go for launch. At liftoff, the Delta II RS-27A engine and 6 of the 9 solid rocket motors will ignite, generating more than 1 million pounds of thrust. The remaining 3 solid motors will ignite about 64 seconds after launch when the first 6 solids burn out.
Minus 2 minutes.
T-minus 2 minutes and counting.
Prop 1, pressurized vehicle launch tank.
Pressurizing.
FAC, establish pulse suppression water on.
Roger.
1 minute, 45 seconds away from launch.
One minute 30.
SSC, hydraulic external power on.
External.
HYE, check hydraulic pressure, go.
1 minute 20.
Topping to 100%.
One minute 10.
SSC, hydraulics internal.
Internal.
T-minus 1 minute.
Rock, report range status.
This is Rock. Range is green.
LC, T-minus 60-second limits on.
And the range operations controller reports that the range is green.
T-minus 45 seconds and counting.
LC, launch enable to flight.
Flight.
ATC-3, main power disable on.
On.
Minus 35.
Hydraulics are go.
T-minus 30 seconds.
Status check.
Go Delta.
Go JPSS.
Minus 20 seconds.
Launch conductor Scott Bunny reports a green board. Everyone is go.
T-minus 6, 5, 4, 3, 2, engine start, 1. And liftoff of Delta II and NOAA's Joint Polar Satellite System 1, making the U.S. a more weather-ready nation.
The Delta II is proceeding on a flight azimuth of 196 degrees, just to the west of 180 degrees south.
Looking good. Also seeing a good symmetric burn across all 6 groundlet solids.
We're listening to the voice of Patrick Moore, ULA flight commentator. 33 seconds into flight, the Delta II rocket will reach Mach 1, breaking the speed of sound.
30 seconds. Chamber pressure on main engine and veneer engines continue to look good. Now passing Mach 1, Delta II is now supersonic.
At 49 seconds, Delta II
continuing
encounters
to see a very symmetric burn across all 6 groundlet
maximum
solids.
aerodynamic pressure, or max Q. This is the point where the mechanical stress in the rocket
Now
reaches
passing
its
48
peak.
seconds, max Q, maximum dynamic pressure.
The 6 ground-lit solid rocket motors will burn out about 64 seconds into flight.
Tail off.
The 3 air-lit motors will ignite a second and a half later.
And we have burnout and ignition of the 3 air-lit solids.
Approaching the jettison of
chamber
the Delta
pressure on
II
the main
graphite
engine, veneer
epoxy
engine
solid
continue to look
rocket
good.
motors in
Gas
3
generator
sequences
fuel
of 3.
and LOX injector
The
pressure.
first 3 will fall away 1 minute 26 seconds into flight, followed a second later by the next 3.
Now 1 minute 25 seconds into flight. And we have good jettison of all 6 groundlet solids.
The final 3 air-lit motors will continue to burn until they are jettisoned 2 minutes 11 seconds into flight.
1 minute 40 seconds into flight. Chamber pressure on the main engine, both veneer engines continuing to remain very stable. Gas generator fuel and LOX injector pressure is also looking very good.
And we're standing
Now
by
passing
for the
2
jettison of the final 3 solid rocket motors.
Chamber pressures on the air-lit solids tailing off in preparation for burnout. And we have burnout of the air-lit solids and good jettison of all 3 air-lit solids. And the booster LOX tank press valve has been open. LOX tank ullage pressure response looks good.
2 minutes, 30 seconds into the flight of Delta.
And main engine and Veneer engine chamber pressures continue to remain very stable.
Once again, listening to Patrick Moore, United Launch Alliance flight commentator.
Now 2 minutes, 50 seconds into flight, now passing Mach 10.
The next major milestone is main engine cutoff, or MECO. The first stage RS-27A main engine
And
will
3
cut
minutes
off.
into flight. Engine operating parameters on main engine and both Veneer engines continue to look good.
MECO is scheduled for 4 minutes, 20 seconds after liftoff. That will be followed.
And it's 20 seconds into flight. Just 1 minute remaining now until main engine cutoff. And vehicle body rates have smoothed out nicely now as the vehicle continues to climb through the upper atmosphere.
Nine seconds after MECO, we'll have separation of the first and second stages of the Delta.
Into flight. Main engine chamber pressure looks good. Both Veneer engine chamber pressures continue to look good. Gas generator, fuel, and LOX injector pressures remain very stable. Vehicle body rates also looking very good. Now at 4 minutes into flight, about 20 seconds remaining until main engine cutoff. Following main engine cutoff, the Veneer engines will continue to burn for a few additional seconds to maintain attitude control, leading up to stage separation. Standing by for main engine cutoff momentarily. And we have MECO, main engine cutoff, and VECO, Veneer engine cutoff. And we have good indication of stage separation, standing by for stage 2 ignition.
The first and second stage, the Delta II have separated.
Stage chamber pressure looks good.
And ignition of the second stage.
And we have a good indication of fairing jettison. And vehicle body rates have smoothed out nicely from the staging events. Now 4 minutes, 50 seconds into flight. The first burn of the second stage will last just under 6 minutes.
The payload fairing that protected NOAA's JPSS-1 during its dynamic flight through the atmosphere has been jettisoned, exposing JPSS-1 to space for the first time.
This first burn of 4 for the second stage on Delta II will position NOAA's JPSS-1 in its correct orbit. The third burn will position a series of CubeSats in their proper orbit, and the fourth burn will be a disposal burn of the Delta II second stage. All of these burns happening over the next hour and 45 minutes.
Now passing 5 minutes, 30 seconds into flight. About 5 minutes remaining in the first burn of the second stage. Vehicle body rates continue to remain very smooth. Chamber pressure on the second stage engine looks good. Hydraulic system pressure on the second stage also looking good. Fuel and oxidizer feed line pressures remain very stable in nominal values.
Six minutes
now
into
passing
flight.
6 minutes into flight.
Listening to Patrick Moore, ULA flight commentator.
And now passing 6 minutes, 30 seconds into flight. 4 minutes remaining until engine cutoff. Second stage engine continues to perform well. Chamber pressure remains very stable. Fuel and oxidizer feed line pressures also remain very stable within family. Hydraulic system pressure also remaining stable. And seeing a nice decay profile on the helium bottle pressure, as expected.
Recapping where we are. The Delta II rocket launched at 1:47:36 a.m. Pacific Time, carrying the Joint Polar Satellite System 1 inside a payload fairing atop of the rocket. The Delta II first and second stage engine with 9 solid
Now
rocket motors.
7 minutes, 30 seconds into flight.
And the Delta second stage have performed well.
Rates remaining very smooth, close to zero on roll, pitch, and yaw body rates. Second stage engine continues to perform well. Chamber pressures and fuel and oxidizer feed line pressures continue to look good. Now 8 minutes into flight.
Coming up on 2 minutes till second stage engine cutoff number 1 at 10 minutes 30 seconds after launch.
And just under 2 minutes remaining now in the first burn of the second stage.
Nine minutes into flight. NOAA's JPSS-1 satellite atop the Delta II second stage.
And now just over 1 minute remaining in the first burn. Second stage engine continues to perform well. Chamber pressure well within expected values. Fuel and oxidizer feed line pressures also remain very stable. Hydraulic system pressure within the expected range. And body rates continue to remain very smooth, close to null for all body rates.
About 30 seconds
30
away
seconds
from
remaining until
second
engine
stage
cutoff.
engine cutoff.
And standing by for SECO 1 in approximately 8 seconds. And we have engine cutoff. Vehicle body rate response is damping out nicely from the cutoff event.
And as you hear from Patrick Moore from United Launch Alliance, SECO 1 is confirmed, beginning a coast phase of just over 40 minutes. The engine will reignite at about 2:38 a.m. Pacific time, 50 minutes, 47 seconds into flight.
This first coast of the second stage should last approximately 40 minutes.
We are awaiting some key milestones in the mission. NOAA's JPSS-1 is scheduled to be deployed at 2:44 a.m. The JPSS-1 solar array is expected to be deployed by 2:50 a.m. And 5 CubeSats are scheduled to be ejected from the Delta II beginning at 3:08 a.m.
And in just a moment, we will be pleased to be joined by United Launch Alliance Program Manager Scott Messer to talk about the success of today's launch.
Now passing 12 minutes into flight. Just over 1 minute into the coast period. Main vehicle systems all appear to be operating nominally. Vehicle battery voltages and currents all within expected values. Helium and nitrogen bottle pressures all at expected values as well. And vehicle body rates all remain very stable.
And we are now pleased to be joined by United Launch Alliance Program Manager Scott Messer. Scott, can you tell us a little bit how the countdown went today?
Yeah, the count was very smooth today. Weren't bothered by several issues that we've been working over the last several attempts, so it was very nice, and the performance is nominal.
Yeah, that was it was a beautiful launch. It was good to see, and we were happy that the upper level winds cooperated. The Delta II has been a workhorse. We've heard that a number of times. Can you elaborate on that for us a little bit?
Yeah, sure, Mike. So the Delta II this is the 154th launch of the Delta II vehicle over approximately a 28-and-a-half-year period. Its first launch in February of 1989 for the GPS mission, and since that time it's launched over 50 satellites for NASA, including Earth observers and weather satellites similar to JPSS. This evening it's launched scientific and interplanetary missions similar to the Spirit and Opportunity rovers, as well as a series of communication satellites. So it's really spanned the entire spacecraft market, and with 154 launches over 28 years, I think everybody would agree it's earned its position as a workhorse in the industry.
Yeah, that is quite the track record.
And when is the last Delta II launch?
So this is the penultimate launch of the Delta II, so we're expecting to launch the last Delta II in September-ish of next year with the ISAT mission, so we're excited for that.
This is a coordinated launch effort by a whole lot of folks, including NOAA, NASA, the Western Range, and United Launch Alliance. NASA LSP selected United Launch Alliance for this launch, and you guys have had quite a string of successes.
Yes, we have. In fact, this will be 122 missions with 100% success as United Launch Alliance. So we're very excited about that, and appreciate the opportunity to launch this critical spacecraft for our customers.
And what is next for United Launch Alliance?
Oh yeah, so it's an exciting year coming up. So still this year we've got the L-47 launch, which launches in mid-December. And then next year we've got a full launch manifest, including 6 satellites for NASA. We start in the March timeframe with the GOES-S satellite, and then Parker Solar Probe in so these are on the East Coast. Parker Solar Probe in July, followed by OFT and CFT, and then back here out on the Western Range, we'll launch the InSight mission in May timeframe. That'll be an exciting launch. It's the first Mars mission to be launched from here out on the West Coast, so that'll be exciting. And then, as mentioned, we'll end with our last Delta II launch of the ISAT mission in September. So it's a very exciting and full year for both ULA and NASA.
Yeah, it sounds like it. You have quite the full plate coming up, and it's going to be an exciting year coming up as well. And we are very excited about how things have gone so far this evening, and we really want to thank you for joining us, Scott.
Well, thank you. Appreciate that.
So as things continue to go well, and we are in the middle of the long coast phase, taking NOAA's JPSS-1 spacecraft to its designated place in space. For now, Tori, we will hand it back to you.
Thanks, guys. So what a beautiful launch we just witnessed. That was truly incredible. We'll check back in at the Launch Control Center later on. For now, let's take a closer look at NOAA's JPSS-1 spacecraft. NASA Edge's Blair Allen spoke with Mitch Goldberg, project scientist for JPSS-1.
Mitch, what is the Joint Polar Satellite System?
Well, the Joint Polar Satellite System, which we call JPSS, is NOAA's new generation of operational weather satellites.
Now, last year we covered the launch of GOES-R. How is JPSS different from GOES?
Well, let me start with GOES-R. GOES-R is a geostationary satellite, so it's at an altitude about 22,000 miles above the equator, and its orbit is moving at the same speed as the rotation of the Earth, so it's always overhead monitoring weather in real time. JPSS is a polar orbiting satellite. It orbits from the North Pole to the South Pole, or the South Pole to the North Pole, at a lower orbit, about 515 miles. And as it's orbiting in that same orbit, the Earth is actually rotating underneath it, and we get global observations. So the global observations from JPSS are critical for weather forecasting. So our primary mission for JPSS is to forecast weather out to 7 days. GOES-R primary mission is to watch weather as it unfolds.
So how are you going to use that scientific data that you get from this polar orbit to do that, to predict weather?
Right now, polar satellite data have been used by numerical weather prediction for years, for the last 20 years. So the information is not totally new. We always had atmospheric sounders. JPSS provides us now with this more advanced capabilities, more advanced observations, and then also the program extends out to 2038, so we have this continuity of critical observations. Now, 85% of all data that goes into weather forecast models come from polar orbiting satellites like JPSS. So it's really a critical data set. So basically the data is processed in this building and it's delivered to the National Centers for Environmental Prediction, and they ingest it right into their weather models, and they basically give updated forecasts. So for example, the Hurricane Irma, if you recall, Tuesday morning, I think it was September 5th, they showed that the forecast would take it Sunday morning right off of Key West. And guess what? That weather forecast was spot on. That 5-day notification, that allowed FEMA to get ready, and state governments to get ready for this major disaster.
Clearly, JPSS does more than just work on weather prediction and forecasting. What are those things that you do beyond that?
So recently we responded to Hurricane Harvey and Irma, and now Maria, with generating flood maps. We used the VIIRS Imager to generate maps of where flooding took place, and that was very important for FEMA for their recovery efforts.
Is there any example of previous weather prediction that didn't have these polar orbiting satellites, and somehow the data, if we'd had it, maybe we could have benefited from it?
Hurricane Sandy is a really good example. If you recall, that 5-day forecast was pretty accurate. It showed that the hurricane was going to move up the coast and make a left hook right into New Jersey, right, in that area. And the European Center for Medium Range Weather Forecasting, they did a study after the fact, and they pulled out all the polar orbiting satellite, which means that all those sounder information was unavailable. They reran the forecast, and guess what? The 5-day forecast showed Hurricane Sandy being way out to sea, way far, like hundreds of miles off the coast, probably 600 miles off the coast. So that was a scenario that was forecast. People would not have been able to prepare for that event, you know. And in reality, eventually the forecast would be right, but it would probably be more like a 2-day forecast. And you cannot prepare and evacuate people with only 2 days' notice. It takes a long, as a good example was the Irma case. It took a lot of planning to be able to evacuate all these people.
And I guess that's why JPSS is planning is a system and planning satellites far into the future.
Absolutely. So when you think of satellites, each satellite has a design life. It can only last so many years. Some satellites are luckier than others, right? Some will last for 20 years, even though it's designed for 5 years. But this information is so critical to the nation that you can't take those chances. So we have a series of satellites from JPS-1 through JPS-4 that will maintain continuity of these critical observations well into the late 2030s.
We are now launch plus 21 minutes and counting, and I'm joined now by the director of the Joint Polar Satellite System program, NOAA's Greg Mant. Greg, congratulations on the launch, and thanks for joining me.
Thank you. It's an exciting time for all of us on the JPSS program.
It certainly is. So tell us, how big of a deal is launching JPSS-1?
Oh, this is a huge deal. You know, the JPSS-1 is part of a National Polar Orbiting Weather Satellite program, and we really need this because 85% of all the data from our weather forecast models come from these series of satellites. So the last one we launched was back in 2009, so we've been a little anxious about keeping this gap to a minimum. So having the satellite up now, and we'll get testing it, so looking forward to getting good data from the satellite.
Great. So now that we've launched, what's next for the satellite?
Well, the first hour is really the booster show, so the Delta II gets to show its stuff, getting us up to orbit. Then the exciting time is we've got to turn it on and connect to our communications to the Satellite Operations Center in Suitland, Maryland. So we'll turn on the communications and make sure that's all working. And then the big deal, we turn the solar array, deploy the solar array, and we start to see the systems power up and start talking and working the satellite.
Okay, so once JPSS is operational, what's next for the program?
Well, the program is really all about continuity. So right away, we'll be working on J2 and finishing that up and doing a lot of testing there. But I think as you saw Mitch just talk about, this is an international program. So we got a lot of partnerships. We take data down from the European satellites, DoD satellites, Japanese satellites, and we're all working with them on their next generation. So we've got a lot of activities here with the Europeans, where their next generation requires a lot of modifications to ground sites. So we're working some ground site changes up in Svalbard and down at the South Pole. A lot of exciting stuff doing there, so we have to work with the National Science Foundation and really beef up the ground system and handle next generation satellites. But it's an exciting time, and it will be for some time.
Well, congratulations once again, and thanks for joining us.
Thank you. Go JPSS1.
Yes. The United Launch Alliance Delta II rocket carrying NOAA's JPSS-1 lifted off from Space Launch Complex 2 at Vandenberg Air Force Base in California about 24 minutes ago. We'll check back in with Mike and Josh at the Control Center in just a few minutes for an update on the count. First, let's turn our focus to the scientific instruments on board this mission. All right, for now, let's take a look. Let's take another look at today's spectacular launch.
We would jump.
Okay,
Right.
Tori, step out on back up here.
So I'm sorry.
Sit back down.
Come on back up. Probably a little bit forward more.
B-19. In addition to NOAA's suite of instruments aboard JPSS-1, NASA is also contributing a scientific instrument called Ceres FM6. Blair from NASA Edge spoke with Ceres FM6 program manager Kevin Dougherty on their Tower Rollback show.
Joining us now is Kevin Doherty for Sirius FM6. Kevin, great to have you on the show.
It's great to be here.
And I want to start right away. What is Sirius exactly? Because it's different from JPSS-1.
It is. So Sirius stands for Clouds and the Earth's Radiant Energy System. We're actually trying to study the energy balance in the atmosphere or in the entire Earth. So the Earth receives a lot of energy from the sun, and as it absorbs the energy, it then reflects some of it immediately, and it emits some other radiation, some longer wave radiation at nighttime.
Now, was there any difficulty for your instrument in terms of riding on JPSS-1? I mean, you're not in competition with them. They gave you a big window for you to get your data?
No, we're not in competition at all. In fact, we actually, as part of our data processing, use a lot of the information from some of the other instruments. So it's great to be on the same ride with them. And actually, in fact, on NPP, the predecessor, we were with some of the same instruments, and it's proven to be a very valuable cooperation.
Oh, that's serendipitous to have that kind of complementary relationship. Now, I'm wondering, this is FM6, which is Flight Model 6.
Yes.
What about the previous 5? Are they still in operation?
So there have actually been 6 previous ones, despite our number being number 6.
Okay.
The first one was a proto-flight model, and that was on trim, and that is no longer in operation. But Series FM1 through 5 are still all up and in flight. So we have 2 of them on the Terra spacecraft, 2 on Aqua, and 1 on NPP.
Okay, so that's great. Now, I understand that JPSS-1 is in a polar synchronous orbit. Wait, no, that's not right. Just polar.
It's sun-synchronous.
Sun-synchronous, but polar orbit. Was that a mission parameter, and are all the other Sirius instruments flying in a similar orbit?
It is. So all of the Sirius instruments are in what we call sun-synchronous orbit, which means that as the Earth rotates, or as the Earth goes around the sun, the orbit rotates as well. So the advantage that we get from that is that we can see both daytime and nighttime, but when we ascend over the equator, when we're passing over the equator, the spot on the Earth below us is always at the same time of day. So that gives us an advantage to see the Earth at the same time, see a little closer up than we would get from a geosynchronous or further away satellite.
I'm noticing this about scientists and collecting data at the right time and the similar time and building this continuous data record that they can look at. Is that a big part of what you're trying to do with Sirius?
It is a big part. And also on the NPP spacecraft, with JPSS-1, we're actually going to be on the complete opposite side of the Earth from NPP so that we'll get a better coverage of the Earth as we move along.
Okay, so is this the last of the series models, or are there more in the future?
So this is the last series in the series, but there is a follow-on coming up. There is a follow-on coming up called the Radiation Budget Instrument, where they are redesigning the technology to try to get an even more accurate measurement.
All 6 instruments aboard JPSS-1 will be providing ground systems with essential scientific data. To learn how NOAA will collect and process the data, let's watch NASA Edge's interview with NOAA's Office Satellite and Products Operations Director, Vanessa Griffin.
So Vanessa, the last time I talked to you was before the launch of GOES-R. And at that time you were telling me that some changes were going to be made to the NOAA Satellite Operations Facility.
Yes.
Have you made them yet?
We have, in fact. You're sitting in the middle of our new operations center. So in the last year, we've totally demolished and reconstructed our entire operations floor where we operate all of our satellites in order to be able to accommodate operations of GOES-16 now, which was GOES-R, as well as the JPSS-1 satellite that launches in November.
Now, are you talking a few cosmetic changes, a table here, a monitor there, or is this a total demo rebuild?
Oh, it was complete reconstruction. So we moved all the operating teams off the floor to different places in the building temporarily. We completely gutted everything in the floor, all the consoles, all the monitors, replaced everything. At the same time, we rebuilt the floor up to hold more equipment and heavier weight. We actually added redundancy to our power systems as well as our comm systems, so that if we had a problem with a unit, we wouldn't lose operations on the floor due to a single failure.
Now we're talking about JPSS-1
yes.
For this show. How are you supporting JPSS-1 here?
Okay, so to get ready for JPSS-1, basically our team had to take that ground system, learn how to operate it, learn how to use it to operate our current satellite, SUMI-MPP, verify that SUMI-MPP could be operated successfully on that ground system and bring it into operations. We just completed that last month. So we now have SUMI-MPP flying on the new ground system, the version that will be used to launch and operate J1. And of course, we then have to get ready for J1. Okay. Learn all the things about the J1 satellite that we need to do to be able to operate it, bring it into operations at launch plus 90 days.
NASA and NOAA are partnering on this mission. Tell us how that partnership works.
Well, it's a good partnership in that, of course, NOAA is responsible for the overall JPSS program, but we rely on NASA to build the satellite for us, in this case also to build the ground system and to launch the satellite. So once we get ready for launch, the satellite launches on the NASA-obtained rocket, and once it separates, then we actually bring it and operate that satellite out of our launch control facility behind the wall here. And that's a NASA team. It's a NASA team of NASA employees and NASA contractors, and supplemented, and of course NOAA is part of that as well, so we're getting used to operating the satellite and seeing how it works. But they operate the satellite for the first 90 days. So over those 90 days, they'll check out all the satellite systems, they'll make sure the instruments are working as required. Anything that's different than they expect, of course, they'll work on how to accommodate those differences, how to respond, any process changes required to actually operate the satellite because of things they see on orbit. And then at launch plus 90 days, they'll hand all of that over to my team, and then we'll start operating the satellite from this facility, this floor, at launch plus 90 days. So we actually embed some of our people with their launch team, the launch crew as you called it, so they get training and they get exposure to the satellite and they know how to operate the satellite. No, it's, idiosyncratic. Every satellite has idiosyncratic behavior occasionally, so they'll learn how to best operate the satellite in an effective way, and then we'll move it into operations at launch plus 90 days, and it becomes mine, or ours, if you will.
Ours, yeah. So in the room here, at any one time, how many satellites are controlled here?
Right now, we're controlling 17 satellites.
In this room right here?
In this room right here. We control 9 NOAA satellites, and we control 7 non-NOAA satellites as well. So like we fly satellites for the Air Force, their Defense Meteorological Satellite Program, or DMSP satellites. We fly them for the Air Force here. We fly our own satellites, and of course we'll be adding J1 in November, 90 days after launch.
Once the data is collected, the question then becomes, how will it be used? NASA Edge interviewed National Weather Service Director Joe Pica to learn how scientists will use the data to learn more about our planet and improve weather forecasting.
And welcome back to NASA Edge. We're joined now by Joe Pica from NOAA's National Weather Service. How you doing, Joe?
Good, Chris. How are you?
You know, Mitch did a great job giving an overview of the JPSS mission. Let's turn our attention now to the user side. How will you, as a weather forecaster and a meteorologist, how will you use that JPSS data in your daily forecast?
So the JPSS-1 data is really the latest in a line of polar satellites, and they're the backbone of all the information that goes into our global weather prediction models. Right. So that's what is used to provide that 3 to 7 day forecast that we get to the public, to emergency managers, so they can prepare for a landfalling storm, forest fires, tornado outbreaks, whatever it is. The polar satellites are the backbone of that data.
Now, when we look at JPSS, I mean, that's the next generation of polar orbiting satellites. GOES-R, that we talked about a year ago, we had you on our show a year ago, is for the next generation of geostationary satellites. So how we have JPSS and GOES work together and get the data that you need?
So both GOES and JPSS are complementary type satellites. So the geostationary is at 22,000 miles above the Earth, and it stays in a constant place to basically look over and maintain watch on the weather, what's coming right now. Where the polar satellites gather the data that feeds into the global models to predict what's going to happen several days in advance.
Okay.
So an example would be Hurricane Irma.
Okay.
For Hurricane Irma, the geostationary is able to look and see where is the hurricane now, what's going on. But then the polar data was used, well, where does it go? Does it strengthen? Does it weaken? Where's it going to be, so we can provide that warning to folks and they can prepare.
So with GOES, I think it's GOES 16 now is what it's called?
That's correct.
So when you were getting that data from GOES 16, if I recall, I mean, you were getting data much faster than the older generation GOES satellites.
That's correct. 5 times faster with the ability to download it every minute if needed.
Now, how is that going to be different than the JPSS data that forecasters will receive?
So whereas the geostationary data is downloading every 5 minutes, the JPSS is orbiting the planet to get global observations, and that's what we need for weather prediction models. So it basically traverses the Earth or orbits 14 times a day, passing over the same spot twice a day, and then we download that data twice in orbit.
Now we have, this is the second in the series, so it's the MPP, or was it Xiaomi?
So Sumi
Sumi
NP was a demonstration project that we brought into operations in 2014 so that we would avoid a gap. And JPSS will be the first of the operational series, and it will be known as NOAA 20.
NOAA 20.
When it gets to operations.
So MPP was sort of bridged the gap between the older polar orbiting satellites with the next generation.
That's correct.
Right. So this is kind of interesting. So all this data that's being collected, I mean, where is that going to for NOAA?
So a couple of places. We feed that into our models.
Okay.
And so those high-performance computers we have run the models so we can issue those forecasts.
Right.
But then it's also stored in our National Centers for Environmental Information so it can be looked at later.
So not just meteorologists and weather forecasts around the country or even around the globe gets access to that data, but also scientists who want to use it for maybe long-term predictions?
That's correct.
Right.
So folks who want to do long-term climate studies can take a look at it later on. I will mention that it also goes to our international partners because weather is a global phenomenon.
Right.
And we actually get data from our European partners from their polar satellites as well. So it's a share so we can all provide that mission to protect lives and property.
Now you went back with Hurricane Irma, and as a public user who watches the Weather Channel and other weather organizations, now you always see these models on TV. You see the European model, the American model, that they have all these different initials for these models. How does JPSS and even GOES, which models do they fit in with that data?
So all those models actually use this data.
Oh, okay.
They all rely upon this data. And we use that with some forecast expertise, like at the Hurricane Center, to issue an official forecast. And for Irma, you'll note that our forecasts were really good and that basically 6 days in advance, the governor of Florida was able to issue a state of emergency to begin preparations before that storm made landfall.
I mean, that's got to make you feel pretty proud that we have a satellite that's up there that's capable of doing something like that.
Absolutely. Our job is to protect lives and property. And when our forecasts, our predictions have enough confidence that decision makers, emergency managers can make decisions several days in advance to protect their local communities, that really is what our mission is.
And the cool thing about it is that this is just the first JPSS one. You're going to have another, 5 satellites going up over the next 5-10 years?
4 satellites. So this is the first of 4.
Okay.
And they basically have 7-year lives.
All right.
And at the 5-year mark, the next satellite would be launched.
Gotcha.
So that we ensure continuity.
And so each satellite will be basically the same satellite with the same instruments on board?
That's correct.
Okay, and that's also the same with GOES. I mean, you're having a series of the next generation GOES satellite that's going to be replacing the older system.
Absolutely. We have GOES-S scheduled to launch in March of next year.
All right, so that's the next one. So where will GOES-S go? Where will GOES-S be in the hemisphere in terms of where it's going to be looking at the Earth?
So GOES 16 is actually going to move to GOES East in December. Okay. So it'll take over its operational role. Okay. We'll launch GOES-Est in March. It'll go through its checkout and evaluation, and it'll become GOES West. We actually have 2 in orbit that are operational, East, West, and then 1 in a backup location in the center.
It's 45 seconds into flight. Now 10 minutes remaining in the first coast period until the restart of the second stage engine. Vehicle systems all continue to look good. Helium and nitrogen bottle pressures remain stable. Seeing consistent vehicle body rates in roll, pitch, and yaw. Very little change in the last several minutes. And vehicle battery voltages and currents also remaining stable.
We're now moments away from spacecraft separation. Let's go back to Delta Launch Control for an update. Mike and Josh?
Thank you, Tori. We've been monitoring the progress of the Delta II second stage. You actually just heard the voice of United Launch Alliance Patrick Moore saying we have about 10 more minutes until restart of the second stage engine. We expect the second stage engine to ignite for the second time at about 2:37 a.m. Pacific Standard Time.
And during the time that we've been away, as you can see on the data-driven animation, The Delta II second stage with the JPSS-1 attached has been performing
and is commanding the vehicle roll rate to null in preparation for the second burn. Vehicle body rate response looks good.
Spacecraft has been conducting passive thermal control rolls to maintain thermal conditioning of the spacecraft, first in one direction and then in a reverse mode. And as you just heard Patrick Moore state, the passive thermal control roll is coming to an end as we prepare for the restart of the second stage engine at about 2:37 a.m. Pacific time, as you said, Josh. So we're about 7 minutes away from that burn. Everything continues to go well. Liftoff occurred on time at 1:47 a.m. Pacific time. The Delta II first stage and its 9 solid rocket motors did their job. First stage separated on time. The payload fairing separated on time. The second stage burned for the first time successfully. A total of 4 burns are planned for this morning. Again, the first 2 will position NOAA's JPSS-1 satellite in its proper place in space. The third will place the Delta II second stage in the proper location to deploy 5 CubeSats, and the fourth burn will be a standard disposal burn for the Delta II.
And we still have some key milestones upcoming. NOAA's JPSS-1 is scheduled to be deployed at 2:44 a.m. The JPSS solar array is expected to be deployed by 2:50 a.m. And those 5 CubeSats that Mike just mentioned are scheduled to be ejected from the Delta II beginning at 3:08 a.m.
We're about 6 minutes away from the restart of the Delta II second stage engine. United Launch Alliance flight commentator Patrick Moore will give us a more detailed pre-brief of the upcoming burn in a couple of moments. Again, everything is proceeding normally. After an on-time liftoff this morning of NOAA's JPSS-1 aboard the Delta II rocket from Vandenberg Air Force Base in California.
And this is Delta Flight Commentary at 45 minutes, 45 seconds into the flight. Now just 5 minutes remaining in the coast period.
Counting down to 4 minutes away from the second stage engine restart. Standing by for an update from ULA flight commentator Patrick Moore.
And we're now passing 47 minutes, 50 seconds into flight. In about 3 minutes, the AJ-10 second stage engine will ignite to start the second burn of today's mission. The second burn will last about 23 seconds. Following completion of the burn, the second stage will enter into a coast for a little over 6 minutes before spacecraft separation.
Two minutes, 10 seconds away from the restart of the second stage engine.
And 2 minutes remaining until engine restart. The vehicle has completed reorienting to the correct attitude for the second burn. Body rates have all been nulled out.
One minute, 30 seconds till the burn.
Now 1 minute remaining until engine restart. And approximately 30 seconds remaining until ignition.
And we are standing by for the second stage Delta II engine to ignite for the second time at a mission elapsed time of 50 minutes, 47 seconds. This will be a burn of about 24 seconds.
And we've seen hydraulic system pressure come up in preparation for ignition. Hydraulic system pressure looks good. Standing by for ignition. And we have ignition of the second stage. Chamber pressure looks good. And vehicle body rates have damped out after the initial startup transients. And we're seeing good oxidizer and fuel feed line pressures.
Cutoff of the second stage engine
Standing
coming
by
up.
for cutoff. And we have engine cutoff. Engine response looks good. Vehicle body rate response looks good. And now entering into a 6-minute coast period before spacecraft separation.
6 minutes before NOAA's JPSS-1 is deployed into space. Spacecraft SEP is planned for 57 minutes, 27 seconds after liftoff.
Now 5 minutes remaining until spacecraft SEP. And the second stage is continuing to reorient to the appropriate attitude for spacecraft separation. Vehicle body rate responses look good.
Live flight commentary being provided by United Launch Alliance flight commentator Patrick Moore.
And about 4 minutes remaining until spacecraft SEP. And looking at the SECO-2 OPUM, the trajectory parameters, the measured parameters compared to predicted values, all very close to the pre-flight prediction. So looking very good on trajectory. And just under 3 minutes remaining until spacecraft separation. And 2 minutes remaining until separation. And now passing 56 minutes into flight. In approximately 1 minute, we will see the separation bolts fire, followed 30 seconds later by final spacecraft separation.
We're now looking at
vehicle
live
body
video.
rates have been nulled out in preparation for spacecraft SEP.
Now looking at live video through the HBK tracking station in Africa of the...
And standing by for separation bolt firing momentarily.
From the Delta II second stage with the NOAA JPSS-1 spacecraft aboard.
And separation bolt firing signals have been sent to all 4 SEP bolts, now standing by for spacecraft separation. Standing by for spacecraft separation momentarily. And we have good indication of separation of the JPSS-1 spacecraft.
And spacecraft separation is confirmed as NOAA's JPSS-1 flies about 440 nautical miles over the Indian Ocean, just east of Mozambique, South Africa, in a nearly circular polar orbit.
Vehicle retro system is fired. Seeing good response on the helium system.
Live view in the Mission Director Center of the launch team that oversaw the launch today.
And the helium retro maneuver is now complete.
Of the Delta II rocket taking NOAA's JPSS-1 spacecraft to space. Next major milestone is the solar array deploy, which is planned for 59 minutes 35 seconds after launch.
And this is Delta flight commentary at 58 minutes 30 seconds into the flight. Now following the successful separation of the JPSS spacecraft, the Delta II second stage will now perform a cold gas evasive maneuver, followed by a short coast period, followed by a third burn of the second stage engine, and which will lead us into the P-pod door openings and CubeSat deployment. And now at 59 minutes into the flight, vehicle systems all looking good following spacecraft separation. Vehicle body rates remain very smooth, seeing good remaining pressure on the nitrogen system, and fuel and oxidizer feed line pressures all remain stable. And additionally, vehicle battery voltages and currents all at good values.
The command for deploying the solar array aboard JPSS-1 scheduled to begin at a mission lapse time of 59 minutes 35 seconds. It'll take about 4 minutes to complete the deploy. The solar array consists of 3 panels folded up before launch and resembling a large wing when fully deployed in space. Photovoltaic cells in the solar array derive electricity from sunlight and convert solar radiation into direct current electricity. The JPSS-1 photovoltaics in the solar array panel will generate more than 2,775 watts and power the entire satellite, including all of the instruments, computers, data processors, and telecommunications equipment.
And now at 1 hour, 1 minute, 45 seconds into the flight, in about 2 minutes from now, the second stage will begin the cold gas evasive maneuver to continue separating the second stage from the spacecraft. And now standing by, in about 30 seconds from now, the second stage will begin the cold gas evasive maneuver. And body rates are nulling out now in preparation for the maneuver. And the vehicle has begun the cold gas evasive maneuver, seeing a good system response on the nitrogen system. And the vehicle has completed the cold gas evasive maneuver. Body rate responses and nitrogen system responses all look good. And the second stage is now entering into a 10.5-minute coast prior to engine restart.
And we'll be back to Delta Launch Control for the third burn of the Delta II second stage engine and the deploy of all 3 P-pods, the CubeSats, slated to begin around 1:48 a.m. Pacific time. For now, back to you, Tori.
Thanks, guys. For those of you just tuning in, you're watching live coverage of the launch of NOAA's JPSS-1 that lifted off on a Delta II rocket just over an hour ago. Spacecraft separation and solar array deploy have been confirmed. We'll go back to the control center momentarily to cover CubeSat deployment. As you heard earlier, there are 5 CubeSats being deployed during this mission. These 5 CubeSats are part of the Alana 14 mission. NASA Edge's Blair Allen spoke with the Alana 14 mission manager, Rex Engelhardt.
Thanks, Tori. Rex, we're really excited to have you on the show for the educational launching of NanoSatellites mission number 14.
I'm excited to be here.
It looks like we're going to deploy, I think, 5 satellites?
There's 5 CubeSats on this mission.
5 CubeSats on this mission. But I forgot, before we go any further, we actually produced a promo for CubeSats, and I wanted to get your opinion on it. Let's check it out.
Fantastic.
When I was a child, I spoke as a child. I understood as a child. I thought as a child. If I put away my childish things, how would I have any fun?
Awesome.
That is cool.
Isn't it great? I mean, I'm sitting here thinking I really do need to take this seriously and create my own satellites.
Have at it.
Well, listen, it's small satellites, right?
They're very. In fact, let me show you sizes. This would be a 3U.
Okay.
A third of this would be. In fact, let me see. This is one unit. Okay. This is one unit.
Yep.
You put 3 of those together, and you get a 3U.
All
or
right.
you can make a 2U.
Yeah.
And you can make a 12U, make 4 of these, or a 6U, 2 of these. There's all different sizes.
This would have been really helpful when I was developing my demonstration model myself, MagnetoStar 1.
Sounds attractive.
Well, it's still in the development stages. But seriously, about Alana 14.
Yes.
You have 5 CubeSats flying on this mission.
Correct, we do. We have 2 3U CubeSats, and then we have 3 1U CubeSats.
Okay, and what do those satellites do? What are their missions?
They're all over the board. We have Buccaneer, and Buccaneers from Australia. That was fun integrating. They guys were getting up at like 2 in the morning in Australia time to talk to us. But that one's looking at some photometry and some atmospheric drag, and they're testing out a new antenna, and they got some other stuff they're doing with it too. And then we have Murata, and Murata is a kind of a test program for a small CubeSat size weather satellite. Really cool technology they're playing with. And we got EagleSat, and that's looking at some orbital decay. They've got a very precise GPS unit, and they're going to look at how the atmosphere interacts with the satellite and causes orbital decay. Then we got MakerSat, and that's an interesting idea. They're looking at, can they 3D print the satellite up at the space station so you don't have to carry it up every time.
Well, that's kind of an impressive idea too, but don't they actually make some satellites out of composite material already?
They probably do. I know definitely parts. I've heard of fuel tanks being printed out of composite and stuff like that. But the idea of MakerSat is a snap-together satellite, and all you do is take the electronic cards up. So you carry how much the rocket has to carry goes way down, and then the astronauts assemble it in the station and throw it out the window.
Brilliant. Yeah. Or just roll the window back up before you. Yeah, there you go.
Then we got RadFXSat, and that's looking at, can we use commercial electronics components in space? How does the radiation in the space environment affect them? Which ones work, which ones don't, and that kind of stuff. And then we had another satellite that we processed along with these in case one of them had a problem, called Dave. And I got to give a shout out to those guys because they worked really hard. Dave was finished, it was ready to fly, but we didn't need them. So what we've done is we've taken Dave, and it's going to fly with ISAT-2 next year in September.
Sounds like that was kind of a backup.
Yeah, it was a backup.
Okay. And then just real quickly, I know a lot of people are involved in the process. Who are the people that integrate this, and how do they get onto the spacecraft?
Well, we have basically two groups that do that. We got Cal Poly built the Peapod, the dispenser that we talked about.
Love those guys. They're great.
It's like a jack-in-the-box with a spring, just throws the satellites out. And then we have the Tyvak was the contractor we use, and they were ones to interface with the spacecraft teams and work with the interface control documents and stuff that all the paperwork and the approvals we need from the FCC and stuff for the satellites.
The cool thing is they tend to go through the same process. Everyone that participates goes through the same process that NOAA would go through or other partners go to when they put satellites on a rocket.
That's correct. We've got safety. You got to make sure nobody gets hurt, both on the ground processing, and you got to make sure everything fits and all the components are there. So the process is very similar.
Well, it's exciting, Rex, and we want to make sure that you have a great launch today. Thanks for being on the show.
It was my pleasure. Thank you very much for having me.
Back to you, Tori.
That was NASA Edge's Blair Allen with Alana 14 mission manager Rex Engelhart. We're now moments away from the release of the first CubeSat. Let's go back to the Control Center for an update. Mike and Josh, how are things progressing?
Thank you, Tori, and welcome back to Delta Launch Control at a mission elapsed time of 1 hour, 11 minutes, and 20 seconds. We do have confirmation of JPSS-1 solar array deploy. NOAA's next-generation polar orbiting environmental satellite is powered and ready to begin its mission to provide greater imaging, increased resolution, and faster coverage, increasing the timeliness and accuracy of forecasts from 3 to 7 days in advance of extreme weather events.
And meanwhile, the Delta II second stage continues to carry 3 Poly picosatellite orbital deployers, or the Peapods, containing 5 CubeSats. And we will stay here on NASA TV to cover their release in just a short while.
Minutes in about 3 minutes, the second stage will ignite the AJ-10 engine for the third burn of today's mission to place the stage into the final CubeSat deployment orbit. The third burn will last approximately 11 seconds. Following the burn, the second stage will coast for 6.5 minutes before beginning the CubeSat deployment sequence. Now 2 minutes remaining until engine restart. Second stage systems all appear to be operating nominally. Vehicle body rates have all been nulled out in preparation for engine ignition.
Once again, listening to Patrick Moore, United Launch Alliance flight commentator, describing the journey of the Delta II second stage with the P-Pods aboard after successfully deploying NOAA's JPSS-1 satellite.
When the Delta II rocket's second stage ignites for a third time into flight, it'll take the P-Pod to their desired location in space. This burn will be just over 10 seconds.
And now 1 minute remaining until engine ignition. Now 30 seconds remaining until engine ignition. And we're now seeing the hydraulic system pressure come up. Pressure looks good. And standing by for ignition momentarily. And we have ignition of the second stage engine. Chamber pressure looks good. Fuel and oxidizer feed line pressures also look good. Standing by for cutoff. And we have engine cutoff. System response looks good. Vehicle body rates damping out, stabilizing nicely after the startup and cutoff transients.
With cutoff the Delta II rocket's second stage engine, we're about 30 seconds away from reaching the P-Pod target interface point. Still several minutes away from actually deploying the P-Pod.
And we're now entering into a 6.5 minute coast prior to starting the CubeSat deployment sequence.
And we're standing by for the ejection of the first P-Pod containing 3 CubeSats. Those CubeSats are 1A, 1B, and 1C sizes, and that'll be EagleSat 1, RadFXSat, and MakerSat 0. EagleSat 1, a 1U satellite built by Embry-Riddle Aeronautical University. EagleSat satellite design team will attempt to measure the decay of the satellite's orbit over time by the means of an unlocked GPS receiver in the space environment. RadFXSat is a 1U CubeSat from Vanderbilt University. Its mission is to monitor ionizing radiation effects in a memory-integrated circuit. The memory, fabricated in a commercial 28 CMOS process supports a low-power sleep mode and will be used to compare the rate of radiation-induced bit errors between reduced and full power states. And MakerSat 0 is a 1U CubeSat from Northwest Nazarene University. Its mission is to measure the mass loss of severely additively manufactured polymers in orbit.
1 hour, 18 minutes, 38 seconds into the flight. About 3 minutes remaining in the coast period prior to the start of the CubeSat deployment sequence. The CubeSats will be deployed 100 seconds apart from each other. And meanwhile, all vehicle systems continue to look good. Vehicle battery voltages and currents within expected values for this phase of flight. Seeing a good pressure remaining on the nitrogen bottle for attitude control. And vehicle body rates are all very stable now in preparation for the P-pod door openings and CubeSat deployments. Now just under 2 minutes remaining until the start of the CubeSat deployment sequence. And looking at the SECO 3 OPM, trajectory parameters for apogee, perigee, inclination all look very close to pre-flight predicted values. Vehicle continues to perform very well today. And now 1 minute remaining until the P-pod door number 1 opening. Now 20 seconds away from the door opening of the first P-pod.
And we are standing by for ejection of the first P-pod containing CubeSats 1A, 1B, and 1C, EagleSat 1, RadFXSat, and MakerSat 0.
Standing by for CubeSat deployment momentarily. And we have good indication of deployment of the EagleSat 1, RadFXSat, and MakerSat 0 CubeSats. And we saw minimal disturbance in vehicle body rates for the deployment. Vehicle body rates have stabilized nicely.
Coming up on the deployment of CubeSat 2.
And we're now 1 minute away from the P-pod door number 2 opening event.
Buccaneer will be ejected from the Delta II second stage. Buccaneer is a 3U CubeSat from the Australian Defence Science and Technology Group that will conduct photometry and outer atmospheric drag experiments and also involve testing the deployment of a 3.2 meter antenna in preparation for future missions that will collect signals from the Jindalee Operational Radar Network.
And standing by in about 15 seconds for P-pod door number 2 open. And we have good indication of deployment of the Buccaneer CubeSat. And vehicle body rates again stabilizing very quickly after the deployment.
And the third and final CubeSat will be ejected from the Delta II second stage. The final is Murata from the Massachusetts Institute of Technology, a 3U atmospheric sensing
and now
CubeSat.
1 minute away from the final Peapod door opening event.
This CubeSat measures temperature, water vapor, and cloud ice in the atmosphere for severe weather monitoring and the study of cyclone structure. Murata will flight test a new ultra-compact, low-power radiometer, as well as new GPS radio occultation receiver and patch antenna array.
And standing by now in 20 seconds for the final Peapod door opening. And we have good indication of deployment of the Murata CubeSat. And the second stage is now entering into a 26-minute coast duration before the final engine restart.
With JPSS-1 delivered into its precise orbit, and along with the 5 CubeSats, we're now standing by for an interview with NASA launch manager from the Kennedy Space Center's Launch Services Program, Omar Baez.
Good morning and welcome once again to Delta Launch Control, where we are very pleased to be joined by NASA Launch Manager Omar Baez from NASA's Launch Services Program at Kennedy Space Center in Florida. We are here at Vandenberg Air Force Base after a wonderful, well-deserved launch this morning. Omar, can you please tell us how things went from your perspective?
Things went absolutely perfect today. The weather cooperated with us and the upper level winds cooperated with us, so the vehicle was perfect, the spacecraft was perfect, the range instrumentation worked great. Couldn't ask for better.
A lot of satisfied customers then.
Absolutely. The nation's got another wonderful weather asset up in space, and we can't wait to have the products coming back from it. It's a real pleasure to work this mission. I know folks have been working on it for a lot of years, and it's well deserved that we get this launched, get our folks back home, and enjoy the Thanksgiving Day holiday. and I do want to thank the entire team for hanging in there with us. It took a little bit longer than we thought, but we got it done. And now we prepare for our next weather satellite, which is GOES, which we'll be doing in March out of the Cape.
And what is next for the Delta II? This was the penultimate launch today.
So we will have the last of the Delta IIs launching the ISAT satellite, and that'll be in September of 2018. It'll be a little bit different Delta II. It'll have 4 solid rocket motors on it versus 9, so it'll be a little bit easier to get out of here, not have to worry about closures coming down in areas you don't want them to. So we should be able to, we look forward to doing it. It's kind of sad to see the Delta II go away, but it's been a great vehicle for NASA. It's been our workhorse vehicle, and it's sad to see it go, but that's the way it goes.
Understood.
Well, thank you. Thank you for joining us. And with that, from Delta Launch Control, we'll now turn it back over to you, Tori.
Thanks, guys. Well, that wraps up today's coverage of the launch of NOAA's JPSS-1. For more information about this mission, visit www.nesdis.noaa.gov or www.nasa.gov. We will now leave you with live launch replays from Vandenberg Air Force Base in California. I'm Tori McClendon. Thanks for joining us.